Right, welcome to this part 7 of our discussion about software redundancy for S7, 300 and 400 PLCs. If you've missed the first episodes, please take a look. There's a link up here. You can go and find the start of this and catch up with where we are now. Right, so up to now we've been talking about software and hardware configuration and how it all fits together and how the program works. Now we can look at how the program is actually set up and started right from the beginning. So right, in OB100, this is the first block of your user program that the PLC runs when it starts up. In OB100, we make a call to FC100, part of the package of the software redundancy. It's called SWR start. Right, and SWR start has got a lot of parameters. It's quite detailed in the instructions, but it's also confusing. If you've been following up to now, it should be a little bit more interesting and more understandable. Right, FC100 requires some information. It requires to know how it's going to communicate between the two PLCs and the ET200 stations themselves. So in here we've got communication. Communication hardware. Okay, and the communication hardware is things like MPI addresses. You need the MPI address of this PLC and of the other PLC. We also need to know station ID. This is the station ID will be either A or B. This is a type char. We don't see that very often in programs, but it's a 1 byte, but it's actually an ASCII byte. And it's either A or B, one of the two PLCs. Now, speaking of all this, what I like to do is have a software redundancy constants DB. Constants. And in the software redundancy constants, I like to put all this information. So I've got a char station ID, and this PLC is A, the other PLC will be, and so on. So in the redundant, I've got this MPI is 2 and partner MPI is 3 and so on. The reason why I do this is because then the constants have names that make sense. And it's easy to search against these things, and it's easy to understand, and the program is more or less self-documenting. I actually have another video up there about specifically about not having what we call magic numbers in our programs. All right, so carrying on. We've got all the communication hardware, the station IDs. We also need to know the addresses of ET200 interface modules. So we need to know all the addresses of the interface modules. We need to know all this type of thing. That defines the communication hardware that we're going to use. Then we also have the control. And that, remember, we discussed briefly about these. We said it's all these DBs. So we've got DB work NO, we got DB RCV NO, we got DB send NO, we've got DB A to B NO, DB P to A NO, and part of the control as well is IDB, the instance data block for the call to software redundancies ZYK. Remember, that was in OB1. Alright, so all these are part of the control. And then we've got also the redundant program state. So in the redundant program state, we need to know the redundant DBs. So remember all these DBs that we were calling in the redundant program. So our program runs on recording the information and the state of the program in these DBs. So we need to know those DBs. In our example, it's 106 to 110. We also, if we are using bit memory, then let's say M100.0 up to M200.0 for argument's sake. And then the last type of thing, we can also have instance DBs for IEC timers and counters. So IEC instance DBs. So we need to know all those as well. And that gives us enough information to be able to record the program state. Also on top of this, either yeah or yeah, it depends on how you want to define it. We've got all the output. So Q0.0 up to Q20.7. Depends on how we configured those in our hardware. You recall we had to set up the hardware for all the outputs of the ET200 stations. So we need to know all those as well. So that we've got. So it doesn't matter, it's all part of the same thing. We can put it anywhere we like, but it's one of the parameters, actually two of the parameters of FC100's call. The first parameter is where do these outputs start, and the second parameter is how many output bytes are there. And the same for all the DBs. Which the first of the DBs and how many DBs are there, which is the first memory byte and how many bytes are we using, which is the first IAC data block, and how many data blocks are there. Right. Then this thing returns two words. It returns the first word is called return val, and the other one is extra info. Now what I like to do, remember I said in our software, when I was talking about the software, I said I have a software redundancy status DB. So in there I record this information that I keep in software redundancy status DB. Remember, this is a DB. This is a DB. And in there I have start return val, and I have start extra info. All right, and that gives me the information. So when I can look at it later on, or I can display it on my HMI or whatever, I can show the state of what happened at the end of the start, because that gives you a lot of these two words together give you a lot of information about how it started up, whether it was successful, and if it wasn't successful, where the problem is. So you can debug a lot of startup problems with these two words. But you need to store them somewhere, because OB100 is called only once. So you cannot look and see what the result was if you don't store it somewhere. So that's that. All right, so if you're enjoying these videos, please like and subscribe. There'll be more coming. And I think that should be enough for you to understand how to do software redundancy. If you have any questions, please put them in the comments below. I'll be happy to answer any questions I can and help you to find further documentation and examples of software redundancy or any of your other questions.